Welcome back, everyone, to the Deep Dive. We love to get into the nitty-gritty here, and today we're diving into something that's, well, pretty fundamental to the whole idea of sustainable materials, and that's the specifications for recovered carbon black, or, rCB, as you've probably seen it written. We're basing this deep dive on a really interesting editorial, actually. It's from rCB News, published just this past April 2025. And the author, well, he's someone who really knows his stuff in this field, Martin von Wolfersdorf.
Yeah, that's right. And we know you're all busy, so our goal today is to, cut through some of that technical jargon you often find in these kinds of discussions. We want to get to the core of what's going on with these rCB specifications. What are the sticking points? What solutions are people proposing? By the end of this, you'll have a much clearer grasp of the landscape.
It feels like, perfect timing for this editorial, too. Martin published it just after that whole series of industry events that happened back in March. We had the Tire Technology Expo, the AZUR Network Partner Treffen, and of course the ETRA conference, the European Tire Recycling Association. It's like he's taking stock of all those conversations and distilling the key points.
Absolutely. And it's helpful to understand where Martin's coming from. He's got this consulting firm in Berlin, Wolfersdorf Consulting, and they work specifically on, well, you could call it circular strategies, basically figuring out how to make industries more sustainable. And his focus is on tires, carbon black, and the petrochemical industry. So he's really in the thick of this.
Oh, yeah. He definitely knows this world inside and out. And I think sometimes it's easy to think of this whole rCB thing as, a pretty niche area. But when you look at the numbers, it's a different story altogether. Martin's newsletter has over 7,000 subscribers, and the rCB group on LinkedIn, almost 1,000 members. So there are a lot of people paying close attention to this. All right, so let's jump in, shall we? Let's talk about where this push for defining rCB specifications even started.
Well, the editorial points to a really important moment, actually. It goes back to October 2021. Martin gets a call from Jake Ronsholt. Now, Jake is the VP of Strategy and Transformation at Bridgestone. Interesting little detail. Martin mentions he was actually at home sick with COVID when this happened. Talk about dedication.
Wow, unexpected circumstances leading to progress.
Yeah.
It's a good story.
It is, isn't it? But the thing to understand here is that this call wasn't just, a casual chat. This was Bridgestone, one of the biggest players in the tire world, saying, we need to get serious about this rCB thing. And they weren't alone. They actually joined forces with Michelin, their big competitor. They decided, let's work together to push this whole recycling agenda forward. And really critical part of that was, well, they needed standards. They needed to figure out how to define what good rCB actually is.
It's a powerful statement when competitors like that team up. Shows they really mean business.
Totally. And they didn't just, talk about it. They actually brought Martin on board to help them get things moving. This was the starting point for what they called the rCB Rubber Work Group. Basically, a collaborative effort to hash out these standards, with Michelin and Bridgestone leading the charge.
So they were really trying to get this conversation going across the industry.
Right. And they took their ideas to a pretty big stage, too. They presented their work not once, but twice at the Smithers Recovered Carbon Black Conference. In those presentations, they laid out their proposals for rCB specifications, like, what this material should actually be, the fundamental properties. But they also talked about classification. So how do we differentiate between, say, different grades of rCB? And they even got into the nitty-gritty of what information should be included in those certificates of analysis, the COAs. It's like a quality control document for each batch of rCB.
So thinking about the practicalities of how this would actually work in the real world.
Exactly. And it seems like they sparked something, too. The editorial mentions that this stuff started by the rCB Rubber Group. It's now being continued by ETRMA. That's the European Tire and Rubber Manufacturers Association. So it's like this initial push has gained some real traction, being picked up by a broader industry organization.
That's good to hear. Now, I'm curious about ASTM, the American Society for Testing and Materials. They're kind of the gold standard for setting, standards across so many industries. Where do they fit into all of this?
Oh, ASTM's a big player here, too. They're definitely involved. The editorial points out that one of their subcommittees, D36.70, is actively working on specifications and classification for rCB. They've got a specific project for this. It's called Work Item WK84831. And this is really important because, having a recognized body like ASTM involved gives it legitimacy. It's a step towards making sure everyone's on the same page when it comes to rCB quality.
But it sounds like it hasn't exactly been smooth sailing. The editorial mentions that ASTM has been facing some challenges getting everyone to agree.
Yeah, that's a key point. You see, over the past couple of years, they've been trying to get some proposed classifications for rCB approved. They have this ballot system, right? But so far, no dice. It hasn't been easy getting all the different stakeholders to agree on what those criteria should be. Even some early proposals, ones that Martin himself thought were pretty good, like one using 4 analyses for classification, even those ran into roadblocks.
It's funny how even what seems like a good starting point can get bogged down, you know?
Mm.
It just shows how complex this is. It's not just about, saying, okay, here's what rCB is. It's a whole ecosystem of stakeholders, and they have to find common ground. So we've got these two main tracks of effort. We've got the industry-driven work now under ETRMA, and then the more formal standards development happening at ASTM. How do these two approaches compare? What are the key differences?
That's a great question. Really gets to the heart of things. Martin makes a pretty clear distinction between them. He sees the COAs, the ones from the rCB rubber group, as very practical, They're like, okay, here's what you need to check for each batch to make sure it meets the basic criteria. Immediately useful for the industry, like a quality checklist.
So the COAs are more about the day-to-day, making sure things are consistent from one batch to the next.
Right, exactly. Now, the classification system, the one they came up with, that was intentionally more high level, more abstract. Martin says the idea was that other folks could then build on it, refine it further down the line.
Sort of like creating the main categories before filling in all the details.
Exactly. But, that hasn't quite happened yet. ASTM D3607U, they've taken some of the classification suggestions from the rCB rubber folks, but not all of them. And they've also added something else into the mix, FT rheology. They think that should be considered for application performance.
Okay, FT rheology. Now that sounds pretty technical. Can you break that down for us a little? What does that tell us about the rCB?
Think of it this way. FT rheology is a way to look at how the rCB, once it's mixed into rubber, how it flows and deforms under stress. Really important if you want to predict, say, how a tire made with that rCB will perform on the road. It gives you insights into things like handling and how durable the tire will be. It is a valuable tool, but as Martin points out later, the equipment for this kind of testing, those RPA devices, they're not cheap. Can cost upwards of 200,000 euros. That can be a barrier for some companies, especially smaller ones.
Yeah, that kind of cost can definitely put things out of reach.
Yeah.
So he's advocating for some alternatives for assessing that application performance, right?
He suggests that maybe DMA analysis should be part of the picture. That stands for dynamic mechanical analysis. You could use it as an alternative or even as an additional method to grade the rCB. He says he'd be fine with that. Maybe even a combination of different tests focused on performance is the best way to go. DMA is another way to look at the viscoelastic properties of a material, basically how it responds to different forces and temperatures. Super relevant for understanding rubber compounds.
So the takeaway here is that we need to look at how the rCB actually performs in its intended use, not just at its properties in isolation. That makes sense, especially given how complex rCB is. So instead of saying, okay, this rCB has this much surface area, therefore it'll behave like this in a tire, you actually test it in a tire compound and see how it performs.
Precisely. That's the shift in thinking he's advocating for. Now, Martin lays out a 4-point proposal in the editorial. A way forward, you could say. So let's dig into those points. What's the first thing he proposes?
Okay, point number 1. Let's hear it.
It's all about clarity, about defining our terms. He wants to strengthen the ASTM DA17822 standard terminology relating to recovered carbon black. Basically making it super clear that when we say rCB, we're talking about an engineered material. Like, it's not just any old char that comes out of a pyrolysis process. It's specifically produced with intention. This distinction is crucial because it sets rCB apart from less controlled byproducts, like simple pyrolysis char. Those can be all over the place in terms of quality, and they're probably not going to cut it for those demanding applications.
So making sure everyone's on the same page about what rCB actually is right from the start. What's the second part of his proposal?
Point 2 focuses on setting a minimum quality standard. It's like saying, okay, for something to even be called rCB, it needs to meet these basic criteria. And he actually gives some concrete examples.
Okay, I'm all ears. What kind of minimum standards are we talking about?
He suggests a maximum ash content. He uses 25% as an example, specifically for rCB made from end-of-life tires, addressing those inorganic residues we talked about earlier. He also suggests a minimum level for toluene transmittance, maybe setting the bar at 80% for rCB from pyrolysis. That's about making sure the carbon-based material is, well, pure enough.
So we're making sure it's not just, random stuff. It has to have a certain level of refinement. What else is on his minimum specs list?
He says we also need to define a range for pellet hardness, how hard those little pellets of rCB are, and a maximum for things like fines, those are the really tiny particles, and also a maximum for sieve residues, which are the larger particles left over after sieving. He says these are still to be determined, and they all have to do with how the rCB is processed after pyrolysis, like how it's made into those pellets for easier handling and transport. And finally, he suggests a maximum particle size for what are called the bound agglomerates. He puts the number at around 10 micrometers to be measured using different analysis methods. Again, all about the physical form and consistency of the rCB.
So these minimum specs are all about ensuring that anything labeled rCB actually has a certain level of physical quality. Now, what about point 3? This is where we get into the classification, right? The different grades of rCB.
You got it. Point 3 is all about how we differentiate those different types of rCB. And Martin's suggestion here is really straightforward. He says we should determine those grades solely based on how they perform in their intended application. Specifically, how they perform in rubber. That's the ultimate test.
Makes sense. It's a practical approach. Instead of trying to predict how the rCB will behave based on its properties, you just test it and see what happens.
Right. So instead of saying, okay, this rCB has this specific surface area, so it'll probably work like this in a tire, you actually mix it into a rubber compound and see how it performs. Does it give you the abrasion resistance you need? That kind of thing.
Exactly. So how does he propose we assess this performance?
He mentions that he's okay with using FT rheology analysis, which we talked about earlier, to understand how the rubber compound behaves. It's the ASTM D8491 standard. But he also brings up a concern. The equipment needed for this kind of testing, those RPA devices, they can be really expensive. We're talking like 200,000 euros. That's a significant investment, and it could be a barrier for smaller companies trying to get into the rCB game.
Yeah, that kind of cost can be prohibitive. So what does he suggest as an alternative?
He proposes that maybe DMA analysis could be used as well. It stands for dynamic mechanical analysis, and it's another way to characterize how a material responds to forces and temperatures. He's open to using it as an alternative to FT rheology, or even as a complementary method. Maybe a combination of different tests is the best way to get a comprehensive picture of how the rCB will perform in a real-world application.
Okay, so we're focusing on real-world performance, not just abstract properties.
Okay.
Now, what about his fourth and final point?
Point 4 looks ahead to the future, and it's all about process capability. You'll often see this referred to as CPIC. Now, Martin points out that right now, we don't have a lot of data on this for rCB because a lot of companies are still scaling up their production. They're not at full industrial levels yet. But he says that's changing fast. He expects a lot of new production capacity to come online next year.
So as the industry grows, the focus is going to shift to how consistently they can produce high-quality rCB.
Absolutely. And he makes an important distinction here. It's one thing to produce a batch of rCB that meets the specifications. You get lucky and it comes out right. But it's a whole other ballgame to have a production process that consistently produces rCB that not only meets those specs, but is also consistently within that acceptable range. That's what process capability is all about.
It's the difference between, getting it right sometimes and having a reliable, dependable process.
Exactly. And he predicts that pretty soon rCB production processes are going to be judged based on their CPK. That's their process capability index. But he says right now, he hasn't seen many rCB processes with a CPK above 1.
Why is that? What's holding them back from achieving that higher level of process capability?
The biggest factor, according to the editorial, is the variability in the feedstock. The end-of-life tires that go into the pyrolysis reactors. The composition of those tires can be all over the place. It depends on what kind of vehicle they came from, the manufacturer, how old they are, what kind of condition they're in. And all of that variability in the raw material affects the consistency of the rCB they're able to produce.
It's like trying to bake a cake when you don't know what kind of flour you're going to get each time.
Exactly. But there is some good news. Martin highlights technologies like Regum tire sorting, which are being implemented to better control the composition of those end-of-life tires. By having a more consistent input, they should be able to achieve more consistent output, which means higher process capability.
So for our listeners who might not be familiar with this term, can you give us a quick explanation of what CPK actually means?
Sure. CPK, or the Process Capability Index, is a statistical measure. It tells you how well a process is able to produce outputs that consistently fall within the desired specifications. A higher CPK value basically means a more reliable process, one that consistently produces high-quality output.
Uh-huh.
It's a way to quantify how well a process can meet the required standards.
So the rCB industry is working towards higher CPK values, which will give their customers more confidence in the consistency of their products. Okay, so this has been a really insightful look at the world of rCB specifications. Now, the editorial also mentioned some upcoming events for anyone who wants to learn more about this.
That's right. If you're involved in rCB or tire pyrolysis, mark your calendars. There are two big conferences happening in 2025, both organized by Smithers. First up is Recovered Carbon Black Europe, which is taking place in Barcelona, Spain, from November 4th to 6th, 2025. And then there's Recovered Carbon Black Asia 2025, which is scheduled for September 4th and 5th, 2025 in Bangkok, Thailand.
Those sound like major events.
They are. Martin says that these two events usually attract around 500 delegates. It's a big gathering for this industry, focusing on recovered carbon black, tire pyrolysis oil, and that whole idea of a circular economy for tires.
Great to know. So, is there still time to get involved in these conferences?
Yes, the call for papers is still open for both of them. And if you're a company looking to get your name out there are also sponsoring opportunities available.
And Martin himself will be attending another event in the U.S. later this year, right?
That's right. He mentioned the Carbon Black World 2025 event happening in Fort Worth, Texas on May 12th and 13th. He'll be presenting there, and he even extended an open invitation to anyone who wants to connect with him for a chat.
Networking opportunity. All right, so to wrap things up, what are the key takeaways for our listeners from this deep dive into Martin von Wolfersdorf's editorial on rCB specifications?
Well, I think the main takeaway is that defining clear and consistent specifications for recovered carbon black is an ongoing process. It's crucial for the growth and acceptance of this material, and it's evolving all the time. The focus is shifting from those basic material properties to a more performance-based approach, actually testing how the RCD performs in its intended application. And as the industry matures, the focus will shift even more towards process capability, ensuring that they can produce high-quality RCB consistently and reliably. All of this requires collaboration across the industry, developing standardized testing methods and adopting new technologies to improve the consistency of the raw materials.
It's a complex challenge, and it's going to take a multifaceted approach to solve it. But it's exciting to see this industry working towards a more sustainable future.
Definitely. Lots of innovation happening in this space.
Absolutely. And it leaves us with some interesting questions to ponder. If we think about the challenges of ensuring a consistent supply of those end-of-life tires, what other innovative solutions might we need beyond just sorting them? And even more fundamentally, how can material science help us adapt rCB for specific applications, even with its inherent variability? Lots to think about there. Thanks for joining us on this deep dive into the world of rCB specifications. We'll see you next time.